In this video, I'll be doing a paper analysis for the 2024 Science Chemistry Practical. For this practical, there are two experiments. The first one is the usual qualitative analysis. For the second one, it may come as a surprise. This is your iodine clock experiment, which is related to the rate of reactions. In the first experiment, which is on qualitative analysis, candidates were given a solution W, which is said to contain a mixture of two acids. So there were a series of 3 tests which will allow you to identify the 2 acids or the anions present in the 2 acids. Now the 3 tests are actually exactly the same as the pure chemistry practical. So the first test is the test for chloride, second test is the test for sulfate, and the last one is the test for nitrate. Now you have done the experiment correctly. The first test would give a white PPT which indicates that chloride ion is present or one of the acid is hydrochloric acid. For the second test, if you have done it correctly, again there should be no observable change, meaning that sulfate ion is absent or the acid cannot be sulfuric acid. And then for the last test, you would see effervescence, and when you test for the gas using your moist red litmus paper, it should turn blue, which indicates that ammonia gas was produced and that the solution W contains a nitrate ion. So with that in mind, that means that the mixture of acids will be your hydrochloric acid and nitric acid. This is pretty straightforward. The second experiment is an iodine clock experiment. Now, clock experiments work by measuring the time taken for a fixed amount of product to be formed. So what is happening in this experiment is that your iron 3 ions in X will oxidize your iodide ions in Y to form iodine. But in this mixture, we have also added sodium thiosulfate in the form of T. So when the iodine is produced, it is immediately reacted away by your thiosulfate ions. Now, since the amount of thiosulfate that we add is limited, once your sodium thiosulfate is used up, is depleted, any excess iodine formed would immediately react with starch, would immediately combine with starch to form a blue-black solution. So that indicates that your sodium thiosulfate or sufficient iodine has been produced to react away your sodium thiosulfate. Now, since the amount of sodium thiosulfate used in every experiment is the same, therefore the time taken for the mixture to turn blue-black would be an indication of the time taken for a fixed amount of iodine to be formed. And based on that, we can calculate the rate of the reaction. So candidates were given a set of values to use for experiments 1 and 2, and you were asked to fill up the values for experiment 3. Now, an important feature of clock experiments is that for each experimental run, the total volume of your reaction mixture must be kept constant, right? Only then would the volume of X be directly proportional to the concentration of X. So in this case, candidates were told to record the timing to the nearest value. Again, don't be alarmed if your values are different from what is shown here, because the rate of reaction is affected by many factors and it's usually quite inaccurate. Now, based on the time values, you were supposed to calculate the rates for experiment 1 and 2 by taking 1000 divided by the time, and we were told to leave the answers to 3SF. Subsequently, you were also asked to calculate the ratio between the rate for experiment 2 over experiment 1. Experiment 2 is the one with a smaller volume of X, meaning a lower concentration of X, so the rate is expected to be lower. The ratio would be less than 1 as well. So based on the values shown, the ratio is actually 0.73. Subsequently, in the next part of the question, you were asked to predict the rate of an additional experiment where the volume of X used was 5. Now, it's important to note that from experiment 1 to experiment 2, where the volume of X is half, the rate became 0.73 times. So the rate of experiment 2 was 0.73 times of 1. So in the additional experiment, where the volume of X is 5, it means that the volume is half of that of experiment 2, meaning the rate of this additional experiment would follow the same proportionality. It will be 0.73 times of the rate of experiment 2. The last part of the question is for students to indicate ways to improve the accuracy. To think of ways to improve the accuracy of the experiment, you can go along the lines of analyzing which parts of the experiment was inaccurate. And obviously, whenever you use measuring cylinder is not the most accurate apparatus for measuring volumes. So one way to improve it is to suggest a more accurate apparatus in the form of a burette to measure volumes of solutions. Now, for pipettes, it's not recommended because pipettes can only be used to measure fixed volumes, so there is a limitation to using pipettes. The other inaccuracy in this experiment would be your human error in detecting the mixture turning blue and then stopping the stopwatch. So one way to improve the accuracy would be to use a light sensor or a calorimeter which is attached to a data logger to set the time to stop or to be recorded when the color intensity reaches a certain value or when the light intensity drops to a certain value. So lastly, I just want to comment that as with the chemistry practical paper, this video is meant for education or recreation purposes. Please do not ask me how many marks you will get for your answer. I do not have the mark scheme and I wouldn't be able to give you an accurate analysis of your marks, right? What is important again is to focus on what you have control over, which is your theory paper. So all the best for your O-level exams.